Alright guys, welcome back. Again, this is your instructor, Mr. K from Code B, and we are almost at the end of this code now. So this is actually the last article that I'm going to discuss. Article 225 on page 78 pertains to outside branch circuits and feeders. So I'm going to go over a couple of things. We do not have too many calculations, a bunch of definitions. I'm going to tell you where to go, what to do, and then go over a few items. And hopefully once we are done, then this will take care of our Article 225. I may mention a little bit of Article 590, but again it depends. But again, 225 on page 78, outside branch circuits and feeders. Okay. So I would like you to please, I'm gonna just tell you where you can go. As I said, we don't have too many calculations, but I would like you to take a look at these sections, highlight, underline, and I think that will be it for us. So on page 78, please highlight section 225.6, which pertains to conductors' size and support for outside branch circuits. So we're going to talk about overhead spans, assuming that power is coming in from the overhead spans and then using poles and utilities. So 225.6a talks about open individual conductors shall not be smaller than the following. So which basically means if you look up there, they are open individual conductors. They are not inside any raceways, any cable. That is what they are talking about when it comes to the open individual conductors. That doesn't mean that we're going to strip everything and then just use just the conductor inside. No, we're talking about the cable. Okay. 225A says for 1000 volts nominal or less. So which means the voltage can be 1000 volts or less. Okay. Then 10 American wire gauge copper or 8 American wire gauge aluminum for spans up to 50 feet in length. Okay. So basically what I did, I drew kind of two utility poles. If the voltage is 1000 volts or less, and the maximum span between utility pole 1 and utility pole 2, or the distance between utility poles or between two buildings is up to 50 feet, then you can use size 10 copper conductors. So in this case, use 10 American gauge copper, and according to your NEC, 8 gauge aluminum. So 8 wire gauge aluminum one. So this one is copper conductor, this one is aluminum one. So again, if distance between buildings and poles is up to 50 feet, then these are the two options, 10 gauge copper and 8 gauge aluminum. Okay. Now, what happens if the distance is greater? Okay. If the distance is greater than 50 feet and there is no support, because it is possible that we can use some kind of support mechanism to hold these conductors in place so they don't sag or hang during windstorms or whatever happens. But the next one says an 8 American gauge copper or 6 aluminum for longer spans unless supported by a messenger wire. Okay, so messenger wire is a steel wire that just supports it. Now, one of the examples of messenger wires is that when you go to these parks and then you look at the utility stores, you see those wires coming down. They are called messenger wires. They are for supporting purposes only. So for lengths for more than 50 feet, for more than 50 feet in length, that way, then we can use size 8 copper and size 6 aluminum. So number 8 copper and number 6 aluminum one. Okay, unless we use a messenger wire, that's a supporting one. Okay, that's part of 225.6a. Okay. Now we also have 225.6.2. Says for over 1000 volts. Now this one is under 1000 volts. Then what happens if we get over 1000 volts? In that case, since now the voltage is higher, current is bigger, then we're going to use 6 gauge copper or 4 gauge aluminum with open individual conductors. Okay. So again, same thing, they are not inside raceways. When we say open individual conductors, not inside raceways. And then it says an 8 gauge copper or 6 aluminum were in cable. Okay, so if you're inside a cable, then of course the sizes are going to come down. So we have more than 1000 and less than 1000 volts. Okay, next part is on page 79, called festoon lighting. Festoon lighting. Okay. Now, basically, what are these? Again, these are fancy lights that basically people put up for birthdays, for any kind of holidays, special occasion, carnivals, cruises, all these little shows that you see, restaurants. So these are the fancy garlandish type lights that are called festoon lights. Okay. So again on page 79, B, festoon lighting. So overhead conductors for festoon lighting shall not be smaller than 10 wire gauge. So the smallest size that you guys can use is 12 American wire gauge. Okay, that's the smallest size, unless the conductors are supported by a messenger wire. Okay, or messenger wires. So they are still talking about the smallest size without any support is size 12. But if you can use smaller sizes if you have some kind of support. Okay, so that's called messenger wire. Again, messenger wire is just a steel wire that does not conduct any kind of current, just basically for supporting purposes only. Okay, so again, overhead conductors for festoon lighting shall not be smaller than 12 gauge unless the conductors are supported by messenger wires. So then it says in all spans exceeding 40 feet, the conductor shall be supported in messenger wire, okay, by messenger wire. So if you are using festoon lighting, any kind of a festivities, then you go past 12, then there must be some kind of messenger wire involved. Okay. Now, before I continue on, I think most of you guys may know or may not know, but when it comes to these temporary lights, remember when it comes to festoon lighting, those lights are temporary lights. They are not permanent lights that you just put them up and then keep them on for the rest of your life. Unfortunately, that is what is happening nowadays, but if you look around in your neighborhood, people set up lights right after Thanksgiving break, and then they stay on for next 30, 90 days, 3 months, whatever the case might be. In some cases, some neighborhoods, lights stay up for as long as somebody keeps them up. But there is a limit. So before I continue on to next sub-article, let's switch to Article 590, because Article 590 pertains to this festoon lighting or temporary lighting items. Because again, as I said, let's say you decide to celebrate your kids' birthdays, maybe your wedding anniversaries, carnivals, or whatever the case might be. Put your lights on in the backyard, or maybe in some cases front yard, depending where you live and how big the front yard is. But they have to come down. They cannot stay up forever. Certain municipalities, localities have about 45 days limit. Then after 45 days, they have to come down. But let's take a look at Article 590 and see what the limitation is. Because there is a strong possibility that we may ask you how long can you keep them up. Okay. So this one is again Article 590, temporary wiring. And then this pertains to festoon lighting. That's why I am going over there. Sometimes people ask me, well, why are we switching to 590? Because 590 is temporary connection. So we need to make sure that things are coming down. So 590 is on page 485. Again, why am I switching to 590? Because it has some time restrictions. It has some time constraints. So we need to make sure that they are up there. Okay, Article 590, temporary installations. So I'm going to read a couple of items, and then we'll come back to wherever we left off. Okay. Again, as I said, when it comes to Article 225, there are not too many calculations. It's just the definitions and little talk. I just want to make sure that everything is covered. Okay, Article 590, temporary installations, page 485. Of course, the scope is 591. It says, the provisions of this article apply to temporary electric power and lighting installations. Okay, so basically it's all wiring. Okay. Now again, when it comes to the lighting or temporary lighting, each city and locality has special requirement. So let's take a look at 591B approval. Temporary wiring methods shall be acceptable only if approved based on the conditions of use and any special requirements of the temporary installation. So that must be approved. So in other words, let's say you're doing some kind of construction, modification, city has to really approve that installation, temporary installation. Or let's say you or setting up or installing these festoon lights or lights of festivals or Christmas lights, whatever lights you're interested in. But in reality, those lights must be approved. And when we buy these lights and bring them home, they are approved for that purpose. Any modification, any alteration without prior consent from your city or anybody else is the code violation, and then against the laws. And then if something happens, the person who does the wiring can end up, God forbid, let's say if something happens, somebody gets hurt. They always say that let's hope that after fire there is no ambulance. That means somebody is hurt or in a serious condition, and then that's where electricians and engineers get into trouble. So that's what you have to make sure that those wires are approved. Okay, so 590.3 is time constraints. That's why I jumped to Article 590. Okay, that means there is a limit. Okay, so 590.3a, during the period of construction, so temporary electric power and lighting installations shall be permitted during the period of construction, remodeling, maintenance, repair, or demolition of buildings, structures, equipment, or similar activities. Okay, so they are only are going to be up for the purpose for which you are going to install them. They are not going to be on permanent basis. So that's what they are saying, during the period of construction. So one more time. So temporary electric power and lighting installation shall be permitted during the period of construction, remodeling, maintenance, repair, or demolition of buildings, structures, equipment, or similar activities. Now let's take a look at part B, 90 days. That is where everything comes into the picture. So whatever you put up, that should be taken down within 90 days or as soon as you are done. Temporary electric power and lighting installations shall be permitted for a period not to exceed 90 days for the holiday decorative lighting and similar purposes. So again, this takes you back to the Christmas lighting, and everybody puts them up, and then people don't take them down. In my neighborhood, there are so many houses that have their lights up throughout the year. Some of them even turn them on at night for whatever reason. The other ones don't, but according to the code, they are supposed to come down. Okay? Within 90 days or whenever you are done, if you are doing the temporary or installations. Item C, emergencies and tests. So it says wiring shall be removed, okay, immediately upon completion of construction or purpose for which the wiring was installed. That's very important, guys. It says a removal. Okay, it says temporary wiring shall be removed immediately upon completion of construction or purpose for which the wiring was installed. Remember the purpose, because sometimes people say, well, you know what, it's just that construction. It is not just construction only. It says for the purpose. So, or the purpose for which it was installed. Well, if you are celebrating birthdays, well, the birthday is done. Within a couple of hours, take them down. Or whatever you are doing. Okay. So this is what you need to keep in mind. And that's why I basically jumped to Article 590, because Article 590 gives us different reasons, different scenarios for these temporary lights or whatever we are basically interested in. Okay. Do we have any questions from here? Well, I'm not at this point sure that you're going to have a question from Article 590, but definitely you will have questions from Article 225 on your exam. Now let's go back. I think that's it as far as Article 590 is concerned. So now we are going back to Article 225, and let's take a look at, again, we came from festoon lighting. So these are those fancy lights, you know, I think you guys got the idea what it means. Now the next part, let's turn to page 80. So that's basically when it comes to outside branch circuits. On page 80, please highlight section 225.18, clearance for overhead conductors and cables. So that's where this guy comes into picture. So clearance for overhead conductors and cables. Okay. Overhead spans of open conductors and open multi-conductor cables of not over 1000 volts. Now they are requiring not over 1000 volts. Nominal shall have a clearance of not less than the following. There are a bunch of clearances. Number one is a 10-foot rule. Okay. So it says number one, 10 feet or 3 meters. So above finished grade. So basically wherever you can stand the finished grade, that applies to basically kind of a pedestrians here. Above finished grade sidewalks. So if you're on the sidewalk, kind of a finished grade wherever you are, or from any platform or projection that will permit personal contact where the voltage does not exceed 150 volts to ground and accessible to pedestrians only. So they gave us a couple of items here. They said sidewalk. So the distance from the sidewalk wherever you are standing to the bottom of the conductor cannot be less than 10 feet. Or the other one is, let's say, they are saying they said sidewalks. They mentioned finished grades, and then any platform, because it is possible that you may have a raised platform, and when you get and stand on that platform, now let's see, you have a raised structure over here. So for some reason this is, let's say, your building or whatever, and then there is a platform, and then people can, you can basically walk up. Okay. So your steps, and you're standing right here. You're standing right here. Well, your 10 feet is not going to start right here, because the problem is you're up, and then 10 feet is going to be between this point and that one. So when they say platform, that's what they're talking about. So the minimum distance from any platform, or you can have a finished grade right here. If you don't get on top of anything, you have a finished grade right here. And then you just have to make sure that the conductors that are passing by cannot be less than 10 feet. But if there's a projection of platform and you need to step up and then you look around, some people have just little steps. So the distance from this part to wherever you can the wires, okay, the concern over here is the conductors can come into your building. That's what basically they're talking about. So they can come in here and be attached to the pole or be attached to the building, but we have to make sure that the point of attachment that you have is at least 10 feet from any platform. That is what we are talking about. Okay. The second part, now this one says 150 volts to ground. That means basically we're talking about 120. Okay. The next part is 225/18.2. Now what they are doing, they are raising the gap because now the voltage is going to go up. So again, over residential property. Now they are talking about residential property, driveways that you have, and those commercial areas not subject to truck traffic. Now remember, here is one thing that I think you guys have to remember. When they talk about trucks, they are not talking about the truck that you guys are driving. In fact, they are not trucks. They are just vehicles, but for whatever reason, people call them trucks. Okay, but this is not what we are talking about here. Those are not trucks. Okay, so again, the gap is 12 feet over the residential property and driveways and those commercial areas not subject to truck traffic. So that means they don't allow, here they are talking about 18-wheelers. Actually, when we talk about truck, and you know that sometimes you see the sign that trucks are not allowed. That is what they are talking about, the big 18-wheelers, not the little itsy-bitsy thing that somebody drives and says, okay, this is my truck. No, that's just a name given to something that is out there. Okay. Truck traffic where the voltage does not exceed 300 volts to ground. And then what they did actually, so we're talking about the driveways, and then we're talking about just residential property. That could be cul-de-sac or whatever. But let's say assuming that this is your house, the driveway. Now the voltage is between 300 to ground, 300 volts, it jumped up. Then the distance from wherever you are, your platform, your finished grade or platform that you're standing up is going to be at least 12 feet from that point to the point of attachment or the conductor. Let's say in this case what's happening, you have, assuming that this is the pole, okay, it is coming in and then there is a point of attachment right here, okay. The point of attachment cannot be less than 12 feet from wherever you are. So let's say you come in and then you attach over here. Well, if you attach your conductor to this side of the building and you're on this platform and you get up and the distance is less than 12 feet, that's a code violation. And in fact, some cities may have their own rules and they say, well, since this is less than this, there's a code violation and I'm not going to basically allow you to do that one. So that's another possibility that we can have some problems. So that's what you keep in mind. Item 3, now they're talking about 15 feet. Okay. For those areas listed in, of course, 12-foot one, classification with the voltage exceeds 300 volts. Now, the previously one was 12 feet, but the voltage was less than 300 volts. So that's basically residential property. We're still talking about residential property, and then driveways, and then assuming this one you're coming in. Now, sometimes people ask me in the past, well, when I look at my conductors, they're way far up. But here you're talking about 12 feet and 10 feet, and what are you talking about? Well, when the power comes into your house, it will be coming either from the top or from the bottom. And mostly it's coming from the top. We're talking about pole mounted transformers and things are coming from the top. And if you look in the old neighborhood and you'll see conductors all over the place. Well, they want to make sure that those conductors are not, you're not touching those conductors. So when we talk about 10 feet, 12 feet area, we need to make sure that if they are coming in and they are attaching to the building or wherever you are, the point of attachment should not be less than either 10 feet or 12 feet. You're out in the residential area when you're walking by, the conductor should not be too close to you. They should be far. So that's what they are basically looking at. Okay. Number 4, now they are talking about 18 feet. Okay. So this is more than just residential now. Now you're moving out of residential area. So where you have big 18-wheelers, 18-year trucks, over public streets. Not residential anymore, public streets, alleys, roadways, parking areas subject to truck traffic. Well, again, guys, make sure that when we talk about truck, we are talking about 18-wheelers. Okay. The distance from the finish grade to the bottom of that conductor that's on the public streets should be at least 18 feet. Now, if it makes you remember, then I think this is kind of a coincidence that we got 18-wheelers running all over the place, and distance is also 18 feet from wherever you are, from the finished floor to the bottom of that conductor. Okay, that is number 5. So again, over public streets, alleys, roads, parking areas subject to truck traffic, driveways, on other residential property and other land traversed by vehicles such as cultivated, grazing, forest and orchard. So that's basically your public street. Everybody's driving by, big trucks are driving by, because most of the time trucks are not allowed to come into just the local area residential property. And the very last one is number 5. The distance is 24.5 feet. That is over track rails of railroads. Okay. So you need to make sure that when you are driving by those tracks, the distance from the track all the way to the bottom cannot be less than 24.5 feet. Now, of course, these are bare minimums set forth by NEC. But when it comes to local areas, city will definitely have its own rules, own policies. So you can basically abide by those rules, abide by those policies. But these are bare minimums. Do you need those? Definitely yes. I'm pretty certain that we get to Code C, somebody's going to talk about that. You can refer back to this page and go from there. Okay, so next part is vertical clearances on page 80. So this is actually part of Article 225.19. It says clearances from buildings for conductors of not over 1,000 volts. Clearances from buildings. Okay. So I'm going to take a look at 225.19. 2. Okay. So in fact, I can look at 2 items here. 225.19C, horizontal clearance. You know, when you're on the building, it could be on the rooftop or whatever. It says clearances shall not be less than 3 feet. Okay, and then if you continue on, okay, to item, let's see, Oh, actually I have to go back, sorry. It's 225.19 A. Clearances from buildings for conductors of not over 1000 volts and nominal. Let's take a look at above roofs. Now you're standing up on the roof, whether it's a flat or slanted, whatever the case might be, they don't care. It says overhead spans of open conductors and open multi-conductor cables shall have a vertical clearance. So when you are up on the floor, rooftop actually, it doesn't matter which part. That, let's say if this is flat, then they're all the same. But if they're slanted, the highest one, from the highest point, the distance cannot be less than 8.5 feet. Okay, so 8 feet and 6 inches. So again, overhead spans of open conductors and open multi-conductor cables shall have a vertical clearance of not less than 8 feet above the roof surface. So again, as I said, if this was a flat surface, there is no problem. It's same everywhere. But if it's slanted, because sometimes people have something like this, then the distance from the highest point to the bottom of the cable cannot be less than 8.5 feet or 8 feet 6 inches. Okay. The vertical clearance above the roof level shall be maintained for a distance not less than 3 feet in all directions from the edge of the roof. So let's say I am standing right here, edge of the roof, and in vertical direction I have at least 8.6 feet clearance. Then they are saying that this distance must be maintained 3 feet from all sides from the edge. So if I go this way, then it should be from the edge. Let's say this is the edge, 3 feet this way. This is the edge, 3 feet this way. If this is the edge, 3 feet that way. And if this is the edge, 3 feet that way. So in other words, no matter which edge you are looking at, that clearance should be at least 3 feet from the edge, because you should not be able to lean over and grab that one. Okay. So again, going up is going to be 8.5 feet, and you maintain that distance all the way around. That's the requirement. So I think that's what I was trying to do, and then jump to something else. Okay. The next part, so again, one more time, before I forget or you forget. So when you are on the rooftop, standing on the top, the distance from the maximum point to the bottom of the cable cannot be 8.5 or 8 feet 6 inches. Okay, 8 feet 6 inches. And then you have to maintain the same distance, at least 3 feet from edge of your house all the way across. Okay. So next part is table or article 225.22. Okay. Raceways on exterior surface of buildings or other structures. Now it is possible, guys, that you might see these raceways outside, and then you might see conductors outside. Then what is happening is that you pull the conductor through it, and we need to make sure that there is some kind of a drainage, even though when you are outside. And then fittings are going to be compression tight. That means water is not going to seep through it, but at least we'll try to make sure the water is not seeping through. But as time passes by, things wear out, the compression, then water goes in. So we need to make sure that there is some kind of a drainage. So you can basically create a little hole underneath or drainage, so water should not get collected inside. Water should not stay inside. that's what they are looking for here. So it says raceways on exterior surface of buildings or other such structures. Okay. So again, raceways on exteriors of buildings or other structures shall be arranged to drain and shall be listed or approved for use in wet locations. So anytime you have conductors outside, anytime you have items outside, you need to make sure that that item, raceway, cable, fittings, they are suitable for outside use. Okay. The next part is 225.26, vegetation as support. So it is not recommended that you use trees as support for your electrical conductors because they are big fire hazard. So again, vegetation such as trees shall not be used for support of overhead conductors. That's absolutely no. Okay. Now, just like our brain circuits that we use inside the house, we need to make sure that the conductors outside have some disconnecting means as well. Okay, there must be a disconnecting means. Now, that could be, of course, that's going to be either fuse, that's going to be breaker, or anything that basically turns it off. So this means, this is Article 225.31 on page 81. So disconnecting means, so means shall be provided for disconnecting all ungrounded conductors that supply or pass through the building or structure. So that means if something happens, we should be able to disconnect those conductors without any problems. Okay. Well, the next part is 225.32 is location. So where do we place that disconnecting means? Well, the disconnecting means shall be installed either inside or outside of the building. I'm pretty sure most of you guys know that either it's going to be outside of your building or somewhere in the garage. Definitely it's not going to be in your bedroom. If it did, then that means it's an old building or apartment complex. Sometimes people may have little sub-panels in their rooms if this is old house or apartment. But other than that, they should be outside and or in garage, but they should be somewhere in readily accessible location. So again, the disconnecting means shall be installed either inside or outside of the building or structure served or where the conductors pass through the building or structure. Okay. And the disconnecting means shall be at a readily accessible location, which means nearest the point of entrance of the conductors, which means that you don't need a ladder, you don't need keys, you don't need anything. You just walk in there and then turn them off. And then for the purposes of this section, the requirements in 236 shall be utilized. So 236, that's another article, not part of this code, but that should be utilized. Now let's go back and review, and I'm going to tell you what you should be able to highlight. Okay. So in this case, going back to page 78, make sure that you highlight section 225.6, conductor size and support. we're talking about overhead spans. 1000 volts typical or less. 10 gauge copper or 8 gauge aluminum for spans up to 50 in length, and then of course if it's more than 50 feet, then you guys have to use larger wire sizes, 8 and 6, if you're not using messenger wire. Okay. Festoon lighting, those very fancy lights that you can basically see somewhere. Once you put them up, make sure that you take them down without any problems, okay? Within 90 days. Okay. So please highlight festoon lighting. Okay. And then the next one is clearances for overhead conductors and cables. 5 different things. Make sure you have enough space for them. For clearance, above rooftops 8.5 feet and 3 feet all the way across. You have to maintain that distance. And then let's see, if you have any kind of raceway outside, make sure that has a drainage. Do not use vegetation as a support. Should have disconnecting means within the accessible location. And then I think that's about it as far as Article 225 is concerned. And that in reality concludes all kind of new material. So please watch these videos, highlight things that I specified and mentioned. And then if you have any questions, please give me a call back, or not call back, but email me and text me. Thank you and have a good day.